These four come from special shapes. So there's two shapes you gotta know. You gotta know a square, you gotta know an equilateral triangle. So the giveaway is the 45. The 45 goes to the square. So if it is half a square, your other half is right there. And 20, the one below it, is actually 10 times easier. So if they give you 5, that means it's 5 by 5 by 5 by 5. And the diagonal, the center of a square, is always 5 times the square root of 2. You can do a squared, b squared, c squared, and find it yourself, but if you memorize the pattern of a square, it's pretty easy. So to get the middle, you times the outside by square root of 2. Now, if they give you the middle and you got to find the outside, you need to take the middle and divide by square root of 2. So you're going to undo the times by square root of 2. So if you divide by square root of 2, you get 10 divided by square root of 2, but you cannot leave a square root on the bottom, so you times the bottom by square root of 2 times top by square root of 2. You got 10 times the square root of 2 on top. On bottom, you got a square root of 4, which is a perfect square. Square root of 4 is 2. And then you can clean up 10 halves. 10 divided by 2 is just 5. So that means your square is 5 square roots of 2 by 5 square roots of 2 by 5 square roots of 2 by 5 square roots of 2. Okay, 19 and 21, so there is your 30. 30, 60, 90 is half of an equilateral triangle. You always flip it over where the 30 and the 90 are. So wherever the 30 is, flip it over the 30. And then equilateral, that's 4, that's 4, that's 4. 4 by 4 by 4. So that's 2, that's 2. And to find the middle of a triangle, it's always the shorty times the square root of 3. Okay, this one's kind of oriented the same way. You're going to flip it over the 30 and the 90, so it's going to flip over there. And now if they give you the middle, that's always the hardest. So we took the shorty and we times it by square root of 3. So we're going to take the middle and we are going to divide by square root of 3. And you cannot leave a square root on the bottom, so times the bottom by square root of 3 times the top by square root of 3. So on top you're going to have 27 square roots of 3, and on the bottom you're going to have square root of 9, which is 27 square roots of 3 over 3. And 27 thirds, you can change that to 9 square roots of 3. That's 9 square roots of 3. That's 18 square roots of 3. That's 18. You just double it. So 2 doubled is 4. 9 square roots of 3 doubled is 18 square roots of 3. Okay, now from quarter 2. Quadratics, if we factor them, that's just rewriting them as multiplication problems. So you are going to take this and work backwards and turn it into a times problem. So it's going to be k times k. Now here's what you're looking for. You need your factor sheet. You're looking for something that timeses to give you 54. It's got to times and give you negative 54, but it's got to add and give you 3. So if you look through your factor sheet and find which one's times to give you 54 negative, so that means one of them's got to be negative, one of them's got to be positive, and you got to add them to get a 6, or add them to get a 3. So it's going to be 6 and 9. The 6 is going to be negative, the 9 is going to be positive, and you can check real quick. If you distribute and times through, k times k gives you k squared. K times 9, that's a 9k. Negative 6 times k is a negative 6k, and a negative 6 times a 9 is a negative 54. And combine your like terms, and that is k squared plus 3k minus 54. And this one, first, before you do anything, let's shrink it down a little bit. Let's divide each of the 3 terms by 4. So if you factor out a 4, it's going to be 4 times n squared plus, that is going to be 16n, and that is a 60. Okay, now we're going to go one more step. Let's turn this into 2 factors. So it's going to be n, well, it's going to times and give you 60, but add and give you 16. And that is a 10 and a 6. And the last one, this one's a special case. These are both perfect squares. So it's not going to be too bad. If it's a special case, we are going to factor this 25r squared. They get that by 5r times 5r, and a minus 16 they get by 4 and a minus 4. So one's positive, one's negative. Now okay, the next one. Solve the quadratic equation for m. So let's get all of our terms on the same side. So I'm going to move these squares over here. So I'm going to minus 4m squareds there, minus 4m squareds. That leaves me with 6m squareds minus 2m plus 2 equals 3m. I'm going to minus 3m. So after I combine all my like terms, get everything on the same side, I have 6m squared minus 5m's plus 2 is 0. And this is not going to factor very nice. So your a does not start with 1 like it did here. That was 1, and after we divided the 4 out, that was 1, and this one was easy because they're both perfect squares. So this one is going to be a mess to factor. So instead of trying to factor, we're going to do quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So once we get everything on the same side, you can identify the value of a, the value of b, the value of c. A is 6, b is a negative 5, and c is the 2. Okay, now you just sing the song, plug them in. X equals negative b, so it's negative whatever b is a negative, plus or minus the square root of b squared. You have to square the negative or else it's going to mess you up. Minus 4 times a times c, all divided by 2a. So if we start to clean that up, a minus minus 5, that's a plus 5, plus or minus the square root. If I do a negative 5 squared, you have to include the negative, so it's got to be parentheses, negative 5 squared minus 4 times 6 times 2. That all simplifies to be a minus 23 all over 12. Okay, now your next move is going to be 5 plus or minus, take that negative out. Square root of a negative is imaginary, so take the negative out, that's imaginary. Square root 23 all over 12. 5 and 12 have nothing in common. 23 cannot pull any squares out of 23. 23 is prime, so that's simplified. So that is your final answer. Okay, now into the circles. So kind of the second half of the quarter. Let's see. Let's see. Okay, so circle K. I think this got scooted over a little bit. Okay. So this picture right here, circle K, the measure of angle HKG, H to K to G is this much right here. That's that angle. So that angle is x plus 10. And I to K to J, that is, where's that? I to K to J is right there. Okay. And I to K to J is 3x minus 22. So that angle is 3x minus 22. Now, those angles are vertical angles. I'm looking one right here and one right here. They're the same. They're equal. So whatever this blue angle is, so is the red one. Because any time you make a cross, vertical angles are always going to be congruent. So the geometry says those angles are congruent. So we're going to do x plus 10 is equal to the 3x minus 22. So I'm going to minus x on that side. And I'm going to have 10 equals 2x minus 22. And I'm going to plus 22 plus 22. So I'm going to have 32 equals 2x. Divide by 2, divide by 2. So I have x equals 16. So if you know x is 16, that means this. If I plug a 16 in, 16 plus a 10, that's going to be 26. So this is 26 degrees right here. This is 26, that's 26. And they want you to find the measure of arc FJ. So this is the arc they want. And to know this arc, we need to know the angle. And now, that angle you can get because that is a straight line. So that's 180. So this much of the 180 is 74. This much of the 180 is 26. So if I take the 180 and I subtract the 74 and I subtract the 26, whatever's left over, that's how much that arc has to be. So 180 minus 74 minus 26 is going to be 80. So that's 80 degrees. And that is 80 degrees. Find the diameter and the area of a flying disc with circumference. Case circumference equals pi times diameter, and area equals pi times the radius squared. So the circumference is 11 pi, so I'm putting that in for circumference. So 11 pi equals pi times diameter. So we need to find the diameter. So solve for d, divide by pi, divide by pi, pi divided by pi. So the diameter is going to be 11. And if your diameter is 11, that means the radius is 6.5. So the area is going to be 6.5 squared times pi. So if you do 6.5 squared, you are going to get 42.25 pi is the area. Okay, circle A and circle B. They need you to find how far it is from Y. So that point is Y and that point is X. And they want to know how far it is YB, segment YB. Okay, so the diameter of A is 10. So that means this much is 5. that much is 5. So all across A is 10. And the diameter of B, so I'm going to kind of separate them out. Diameter of B is 8, so that's 4 and that's a 4. Alright. So from here to here is 5. And from here to here is 4. Okay, now from A to X is 3. So if this A to X is 3, that means the X to Y has to be 2, because from A to Y is 5. And if this is 2, this has to be 2, because B to X is 4. So Y to B is 2. Okay, the diameter of C is 18 long. You need to find the arc length. So if you've got circle C, the diameter is 18, so that guy is 9 and that guy is 9. And you need the arc of a 100-degree arc. So 100 degrees, something like this. So if you have 100 degrees right there, so that's 9, that means this arc measures 100 degrees. Okay, now they want the length of it. They want to know how long it is. If you're walking from here to here, you walk 100 degrees, you rotate, but length is distance. So here's what we need. We need the circumference. Circumference of the entire circle is if you start here and you walk around the whole circle. So circumference depends on how big your circle is. So this circle is 18 tall. So circumference is pi times diameter. So it's 18 pi. Now that's all the way around. So here's what we're comparing. We're comparing 100 degrees to the full 360. And I want to know just this distance to the full distance of the circle, which is 18 pi. So we're going to compare degrees to degrees, so 100 to the full 360, and we're going to compare length to length. And we don't know this length, that's what we're trying to find, but we know the whole length is 18 pi. So once you got a proportion, you just cross multiply. So you're going to do 360 times x, that's 360x. Now you're going to cross this way. 18 times 100 is going to be 180 pi. So now solve for x, divide by 360, divide by 360, and we've got x equals, so you do 180 pi, and they want it in a decimal, so I'm going to do 180 times pi divided by 360, so that arc is 1.57 units. Oh, we already did this one. So circumference is 11 pi. That's this guy we did just right here. So I forgot to delete it.